A lot of times in math, both in algebra and other mathematical disciplines, it's very useful to get rid of a radical in the denominator. And we do this by multiplying both the numerator and the denominator by an appropriate expression. And this is called rationalizing the denominator. Let's suppose the denominator consists of a single term that looks like the nth root of a to the m. So we want to figure out what we need to multiply by. And we would multiply by the nth root of a to the n minus m. The reason we would do this, when you multiply, you add exponents. So this is m plus n minus m, which is the nth root of a to the n, which is just a, or the absolute value of a, depending on if n is positive, even or odd. So let's look at a few examples of this. 5 over the square root of 7. In this case, we're just going to multiply by the square root of 7 over the square root of 7. On the top, you get 5 times the square root of 7. On the bottom, 7 times 7 is 49. So we end up with 5 square root of 7 divided by 7. What about 1 over the cube root of 6? Well, we have 1 6 on the denominator, but to cancel the cube root, we need a total of 3. So I'm going to multiply by the cube root of 36. On the top, I get the cube root of 36. And on the bottom, the cube root of 6 times 36, which is 216. And the cube root of 216 is just 6. So I get cube root of 36 divided by 6. The 9th root of 1 over x to the 4th. One of the properties we looked at said that this could break up as the 9th root of 1 over the 9th root of x to the 4th. And the 9th root of 1 is just 1. We have 4 x's on the denominator, and we need a total of 9. So we need 5 more. This will give me the 9th root of x to the 5 on the top, and the 9th root of x to the 9 on the bottom. Or the 9th root of x to the 5 divided by x. So far, all of my examples supposed I had just a single number on the denominator, but what if that's not true? What if I have an addition or a subtraction on the denominator? In that case, we're going to multiply by what's called the conjugate. So if the denominator is something like a plus the square root of b, the conjugate that I would multiply by would be a minus the square root of b. And that's because if we do this and we multiply it out, you would get a squared minus b. And I won't go into the details of multiplying this out just yet. We would essentially just need to FOIL it, which I will talk about in a later video. But let's look at a few examples using this. 1 divided by 2 plus the square root of 3. Now what I need to multiply by essentially just changes the sign in the middle. On the top, 1 times anything is just itself. And on the bottom, like I said, you would square the first thing, 2 squared, minus squaring the square root, which would just give me 3. So I have 2 minus root 3 over 1, or just 2 minus the square root of 3, which seems much simpler than what we started with. There's also no reason why this is unique to the denominator. You can also rationalize the numerator. So in this case, I want to get the square root off the top. In order to do that, I multiply by the same thing, but just change the sign in the middle. So 1 plus the square root of 5. I square the 1 minus the square of the square root of 5, which is just 5. And then on the bottom, 2 times 1 plus the square root of 5. That gives me negative 4 over 2 times 1 plus the square root of 5. And negative 4 divided by 2 is just negative 2. Wrong thing. So negative 2 divided by 1 plus the square root of 5.